So if you were here yesterday, a lot of this is going to be similar. You're going to remember it. Starting out with this little formula right here. I'll bring it up again when we get to the homework. This is just a modified quadratic formula. We've been writing it the last few days like this. You know, we talked about how it's a squared plus b squared equals c squared. You can call the sides anything you want. So this is just taking the square root of both sides, right? R equals the square root of all that. Why is this nice? It just kind of cuts to the work without having a lot to do. You use this when you have the x and the y and you're missing the r, because on the unit circle, radius is always positive because it's a hypotenuse. So you've already done the square root. We don't need to worry about plus or minus and all that stuff, okay? So you don't think of it as a new formula. If you don't remember it at some point when you're doing a test or a quiz, Pythagorean theorem works perfectly fine, okay? But I'll point it out to you when we get to the homework. Also, I'm getting so nervous about the video. I just keep looking at it. So I want to remind you that sine, and I'm only going to be talking about sine and cosine here. Sine is opposite over hypotenuse, right? We remember SOHCAHTOA. If you need to write it, feel free. So sine is opposite over hypotenuse, right? And cosine is adjacent over hypotenuse. So let's take a second and look over at this picture. Ignore all the stuff written in there. This is a quadrant 1 angle. You can see we could drop down to the x-axis, make a right angle, theta's by the origin, all the stuff we've been going through every day. Again, ignore all the stuff. Starting here, how do we get to this point? We go to the right x units, up y units, right? And then we have our radius here. So all the parts that we've been talking about all along. So we could also think of, because of what I just said, sine is also, instead of the side opposite, let's give the opposite side a name, like y, and let's call the hypotenuse r. So sine could also be y over r in this picture. They could put any letters there, right? It's about where they are, not really about the name. And so what I'm going to do with this formula, and you'll understand why in a moment, is I'm going to solve for y. I'm going to get y by itself. So if I multiply this side by r and this side by r, the r's would cancel, and I'd be left with y equals r sine theta, r times sine theta. It's just rearranging this formula. That's it. It's rearranging this little equation. I can do the same thing with adjacent. With cosine. Cosine is adjacent, which we've called x in this picture, over hypotenuse, which we called r. So cosine of theta equals x over r, and let's isolate the x, get x by itself. Multiply both sides by r, r's cancel, and then I'm going to put x over here. X equals r times cosine theta. So what we have here are two, again, I'm going to use the word modified equations, formulas that we can use to find x or y. Did we have to rearrange to find it? Not really, but it makes it so much easier. And here's when we do this. So let me go down here to this example so you can understand when we use those two formulas, okay? So here we're given an angle measure of theta is 4 pi over 3 in standard position and a circle with radius of 5 centered at the origin. Find the coordinates of point x, y. Now they drew the angle for us. It's in quadrant 3, but we should already know that because this is 4 pi over 3. Okay? So on the unit circle, what are all the radii? 1. That's why it's called the unit circle. All the radiuses are 1. All the hypotenuses are 1. Okay? Here they're changing it. So if this was just on the unit circle, or if the radius were 1, what is this point? We would go, 4 pi over 3, just like you did on the unit circle, and grab that ordered pair. But since they changed the radius from 1 to 5, we have to use we're going to use this formula. It makes it so much easier. So let me show you what I mean. X equals r, I'm going to rewrite the formulas. Nope. X equals r cosine theta. I knew I was wrong because x and cosine go together. Okay? I meant to do that. And y equals r sine theta. Easy to remember. So what we're going to do is just plug right into it. So radius is 5, right? That was given to us. And then times cosine of this angle. We're going to do the same thing over here. 5 times sine of 4 pi over 3. Okay? So what is cosine and sine of 4 pi over 3? Well, it comes from the ordered pair that goes with 4 pi over 3. Remember, we look at our denominator. Anytime you have a denominator of 3, we start with 1/2. Those are the angles closest to the y-axis. And we're in quadrant 3, so everybody's negative. So I'm just going to plug those numbers right in here. 5 times cosine of 1/2. And when I simplify that, I get negative 5/2. Remember, it's just 5 over 1 times negative 1/2. Multiply your numerators, multiply your denominators. Sine of 4 pi over 3 is, I'll write it like this. So it's 5 over 1 times negative 3 square root of 3 over 2. So y is negative 5 square roots of 3 all over 2. So the ordered pair, be all proper and write it in parentheses here. So when you change the radius from 1 to something else, you got to use this formula. Before it was a 1. Radius was 1, so the answer didn't change from this. Okay? But when the radius changes, we have to change our math a little bit. Okay? We'll use it again in a moment. Yeah. So from the unit circle. Yeah, it's the ordered pair for that. And then sine is y. That's right. Yep, right from quadrant 3 that we just did. You okay, sweetie pie? Can you go get a drink of water? Yeah. Yep, and you'll see it again here in a second. Okay, so yesterday and today, it's all about these right triangles. Figuring out what quadrant they're in, unless they're told, right? What did you give me? What do you want from me? Okay, from the question. So if theta terminates in quadrant 2, thank you for telling me where it is. I don't have to play little games to figure it out. And cosine, let me see, I'm just right over here. Cosine is negative 1 over 3. Find the value of sine theta. Do you need the Heimlich? I can try. Might hurt you. That's strong. Oh, really? Then you have to do, oh, yeah, we'll talk about it later. Okay, so they're giving us that. They want us to find that, okay? So cosine is negative 1/3. All right, so let's draw this triangle in quadrant 2. It's already started for us. Thank you very much. We learned how to do this yesterday, pretty much in every quadrant, I think. Remember, your right angle is always with the x-axis. Theta is always at the origin. And we know sine is opposite over hypotenuse, so we're messing with 3 sides of a triangle here. And we know that cosine is adjacent over hypotenuse because of SOHCAHTOA. So adjacent is here, and hypotenuse would be here. So for sine being opposite over hypotenuse, I'm missing my opposite side, right? I need this side. When I have 2 sides of any right triangle, I can use our old standby Pythagorean theorem, right? So x squared plus y squared equals radius squared, a, b, c if you want to. Okay, remember, the letters really aren't that big of a deal. Subtract 1. When you do the square root of 8, y'all, you have to simplify it. You always have to simplify fractions. You always have to simplify radicals. The square root of 8 is 2 square roots of 2. So let me remind you where that comes from. And this one pops up all the time, so it's a good one just to memorize. So 8 is 4 times 2. The square root of 4 is 2. Okay? I don't think we've had to simplify any radicals yet. We've had all these numbers that can't be simplified. But if you get one, it's required. Okay, so and since it's we're going up on that side in quadrant 3, we're going to use positive 2 square roots of 2. That's our opposite side, right? Our opposite side would be our numerator over the hypotenuse. And that's all they wanted, was sine. Okay? Try to separate that. Okay. More code here for us. Find all the values of theta between 0 and 2 pi, including 0, where, now you got me coughing, where cosine of theta is 0. Okay, so let's break this down. Right here is kind of some new notation for you, this year anyway. This is code for unit circle. You see. These are the thetas in between 0 and 2 pi. And even though this is a big misconception that 2 pi is on the unit circle, it's actually not. When we talk about the unit circle, it's from 0, including 0, up until you get to 2 pi. Okay? So we don't really include 2 pi in the unit circle. Okay, and what the question is, where on the unit circle? What are the angles? Let's do them in radians. Where are the x values zeros, right? That's what that's saying. We don't care about the y values, but where does this happen? What angles? So you know it's not your square root of 3 over 2, 1/2, square root of 2 over 2, so you know it's got to be those quadrantals. So picture it in your head. Don't open your binder and go to your pink sheet. Picture it in your head. Where are the zeros of x? Left and right, it's 1 and -1. So, oh, it's up and down, right? Picture it. This is 0, 1. This is 0, -1, right? So theta is 0 at pi over 2 and 3 pi over 2. Remember, those are our two angles that have a denominator of 2. The only ones, the only angles that have a denominator of 2. Okay? We're almost done. Remember I said sometimes we have to interpret another language basically to find which quadrant our triangle is in. Here's one of those. If tan of theta is 4 pi over 3 and cosine of theta is less than 0, find sine and cosine. Okay? And find the coordinates. So you can see she left it blank. She's not giving anything away to us in the notes. What you might have been laying in bed wondering about for the last few days is, why did my teacher, my favorite teacher, give me this all students take calculus business, because she hasn't talked about it since then. Here's the moment where I do. If you go back, next year when you're in calculus, you'll use this all the time. I just took a calculus class at SPC, and if you look through my problems, you see this all the time. It is a nifty, great word, nifty little trick to figure out what quadrant a triangle is when things are written in code. Okay? So let's just start with this one. Cosine of theta is less than 0. Anybody know what that means? Negative. If you're less than 0, you're negative. Cosine is negative. That's what that means. Why don't they just say it? I don't know. We can figure it out, right? They're also telling us tan of theta is 4 pi over 3. It's positive, right? Tan is positive. Now look what this let me remind you what this little diagram or whatever means. It's the 4 quadrants. All students take calculus to help us remember it. These letters tell us who is positive in each quadrant. So all are positive. Sine, cosine, tangent are positive in quadrant 1. Only sine in 2, only tan in 3, only cosine in 4. Which means, by default, if you're not one of those letters in those quadrants, you are negative. Okay? So let's just start with cosine. If cosine is negative, what two quadrants do we get rid of immediately? 1 and 4, right, Esther? This is where cosine is positive. This is where cosine is positive. If cosine is negative, we know we're not in that quadrant, either of those quadrants. And if tan is positive, it's narrowed down to 50-50. Well, tan is negative here, and it's clearly positive here. So by process of elimination, you can figure out which quadrant you are drawing your triangle in. Yes? Tan is positive. Tan is positive. This is, remember, these letters represent where we are positive. Where we're positive. So I got rid of 1 and 4 because everybody's positive there and cosine is positive there. But in our directions, we want where cosine is negative. Okay, so that left these two. Tan is positive. Well, it's not positive here. It's clearly positive here. So we definitely have our triangle in quadrant 3. And tan is opposite over adjacent. But don't forget, quadrant 3 is tricky. Everybody, I did that wrong. Opposite over adjacent is up here. So sorry. That's my hypotenuse, right? I'm so sorry. But don't forget, in quadrant 3, everybody's negative. We don't see the negatives here because a negative over negative is positive, so it's been simplified. They want us to find sine, cosine, and the coordinates, which is just sine and cosine in the correct order. So guys, to save time, we need the hypotenuse. We can do Pythagorean theorem, fine, but this is a 3, 4, what triangle? Do you guys remember? 5. This is a 5. And it's positive because it's always a hypotenuse. But if you didn't know that off the top of your head, of course, 2 sides given, you can find the third side using Pythagorean theorem. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. If I wanted to write it as an ordered pair, cosine goes first, sine goes second. Don't forget, cosine, sine, alphabetical order, C and S. Last problem, very quick, just teaching you something on your calculator. See the calculator? Basically, we want to know what this point is right here. And this is what we're given, right? We have a radius and we have a theta. We want x and y. We just learned a formula for that. Think about what you're given, what you need. How do we find it? So the radius given, theta given. Now, when we did this problem a few minutes ago, it was an angle we knew a whole bunch of information about. It was 4 pi over 3. It was a unit circle one. So we just grabbed it from our brain. But this is 25 degrees. It's between 0 and 30. We don't have that memorized. This is where we use our calculator, okay? Literally, we're going to put this in our calculator and get those x and y values right now. So what I want you to do real quick is clear your RAM, second plus 712. Clear your RAM and go to mode. Because we are in degrees right now. You have to tell your calculator that. All calculators, scientific and other, default to radians, believe it or not. So you have to go to mode, and there's literally a button called mode. Mode, right here at the top. Hit mode and go to the third row. And you'll notice radians is highlighted if you cleared your RAM, because last period already did this. So if you cleared your RAM, radians is highlighted. You're just going to move your arrow over to degrees and just hit enter. And that moves the highlight onto it. So you are now in degree mode. And you have to be because we're in degrees. So hit enter, or you can hit enter, you can hit, no, enter won't even work. You can hit clear. You're not clearing it out, okay? You'd have to move it. And just type it in. 14 times cosine 25. You don't have to hit the times symbol, but you can if you want to. Find cosine and round to 3 places. All right, yep. Do the same thing for sine. 14 sine 25, enter. Now if you forget to change your mode, it won't give you an error message. You can figure this out in radians or degrees, but your answer will be different. You won't realize that you didn't change your calculator. So I'm annoyingly going to be saying to you so much, change your mode, or check your mode, check your mode. You guys are going to remind each other of it before the AP exam. Check your mode. Everybody check their mode. I'm going to train you to say it, because I can't be there with you. Because you're going to do a lot of trig on your calculators, and you have to be in the right mode. Okay? That's it. Exciting day. Vladimir, you okay, sweetie? I was going to be a nurse, remember, but I failed chemistry.